Okay, last time we're already talking about C++. And let's see how far we go. Okay, so basically you understand the program will be stuck with the function man. That's what you can see here. Okay, when they get a man here, they get an open, they get a close. They will be a function. Okay, the parentheses open close following the word man that distinguishes feature of the function. Okay, and also make sure you understand program statement. Each statement must be ended with a semicolon. And white space ignore. Okay. Also, when we're talking about string constant, okay, they surrounded by quotation mark, like hello. First thing you need to recognize what is it. The second thing is how they work. Okay, when you see a double quotes, then you know that's string constant, and they cannot be given new value while the program running. Okay, and the next could be processor directly start with the power sign, like you say include whatever iostream.h. This header wrote by Microsoft. They doing everything for you. So when you want to use, you need to use include. However, make sure you understand they must be stuck with the power sign and no semicolon. The thing is, if you have to understand that, when you edit the program, you compile, and that's why you not get error. Otherwise, when you get an error, you know right away what the error, okay? Command we already know, okay? Decoration. Decoration introduce variable names in the program and specify its type. Like last time I already telling you. You say A equal 20. Basically, compiler don't understand what is A. So that's why before you using A equal 20, for example, you have to make a declaration. Tell the compiler what is A and the type. So that's why I said integer A. Okay? A is a variable. If you're talking about software, if you're talking about the hardware, it's just a location or address inside the computer. When you say integer A, that means the computer will give you the room with the name A to contain any information with the size of 16-bit or 8-bit, okay? So you can store the value without decoration and you get an error. And what they say, must declare variable type before you can use the variable. Okay. Now, variable names on uppercase and lowercase letter, no big deal. That's why when you try to get log in your email, okay, and they can asking you your username, they will be the same thing here. Username, they can use uppercase, lowercase, no big deal. Digit from 1 to 9 and the underscore. First character must be a letter. That's why you can say you create your account in the email, you cannot enter username with the first number. They have to be a letter. Okay? As long as desired, you get a maximum 32 character. So that's very good. Cannot use keyword or keyword identify for a language feature. That means some keyword using in the program, for example, for, that means for loop, if statement, okay, or do, that means just a forward. Assignment statement. If you say VAR equal 20, the equal sign in above example cause value on the right to be assigned to the variable on the left. That's what we call assignment. When you see VAR equal 20, then you know that assignment. Okay. Integer constant. The number 20 is an integer constant. There is no decimal point in the integer. Output variation. Now you can see in the lab software, they're using print, whatever they want to print it out. However, in the C++, they're using the C out. What that operation? Who remember, tell me. What the name of this operation?
It prints to the screen?
Now I want the name of this operation. Yeah, I understand they will be displayed on the screen. But for the guy to learn it, and you need to know what the operation here.
You're assigning the
No. That's what I telling you. You have to read 100 times. You're able to understand.
Is it the character output?
No. Who else keep telling me? What did operation? Yeah, who tell me? Is it Mr. Smith here?
Is it insert?
Very close. That's what we call instruction operator. Instruction operator. Okay? Now, you tell me the next one. The value of variable. What is it?
That's a string.
We already told you right here. String constant. Okay? That means that inside the double quotes, double quotation, that means string constant. Okay, so if you want to display on the screen, you must be using Cout. And then have to be instruction operator. Whatever you want to tell the people, they will be in string constant. My next question is, what VAR? What?
That's a variable name.
Variable. Okay. So when they print, they not print VAR1. They will be print whatever content in that variable. Okay. So the above example will display the value of VAR1. Okay. Make sure any confusing, then just let me know. You must be understanding, not try to memorize. Okay. Character variable, they're using CHAR, and they will be only occupy 1 byte of memory. Character constant. Okay. This is just let you know. Character constant use simple quotation mark around a character. For example, A will be stored in 8 decimal ASCII code. That's the American, right? Standard. Okay. Initialization. Variable can be initialized at the same time they are defined. You understand what that means? If you say integer A, okay, that means you want to get the variable name A. Later on, you say A equal 30th. Now, also, they said you can do this at the same time. Copy that one. Okay, you can say integer A, and you can assign to be equal 30. Right after that, That'd be fine. That's what they said. Okay. Add cap sequence and add cap character change the meaning of character that follow it. For example, n is a letter, but /n is new line. Okay. So you understand what they mean for new line. That means go to the next line. Okay. For example, when you say /n, that will be new line. And also they will be the same with what they call an line. Okay, so you're using a /n, they the same like you say n line. N line, that means after this line, they go to the next line. Okay, and the rest of that one, you can read it like the backspace and a double quote. That doesn't matter, we're not using. Okay, and also we already said variable is a location in your computer memories in which you can store a value and from which later on retrieve that value. So that one, they given you the name of variable type. They can be unsigned short integer type. They occupy 2 bytes and they given you 0 up to 65,535. Short integer also occupy 2 bytes and they given you value from minus 32,000 up to 32,000. Okay, so now I can tell you, if I asking how old are you? Okay, now when you answer, you can type in 70, 60, 65, whatever. However, you need the variable to hold that value. Then you understand it. Before that, you can say integer. My age. Okay. Then later on, whatever you answer, they will be stored in my age. However, my question here, you want to define as unsigned short integer variable, or you want short integer? If I say short integer, they working, but not really good. I want it to be unsigned short integer. Unsigned short integer. So which one you prefer? They working, no big deal. But what I try to bring it up to see how much you understand. You can say short integer my age, or you can say unsigned short integer my age. So telling me which one you want, first one or second one?
Either one works. I mean, for the,
Yeah, that's what I said. Both is working, no big deal.
okay, then go with a short. Short and
You go with short.
Yep.
Now I'm telling you, if you're looking here, short integer, they given you the value from minus 32,000 up to 32,000, correct? You see that? Minus 32,000 to 32,000. However, unsigned short, they given you 0 to 65,000. So I like the unsigned short integer. Why? Who knows?
You're only expecting positive values of the age.
Exactly. The thing is your is only positive, not negative. So that's why I picked unsigned short. Okay? That's just for understanding. However, either one, they still working. Okay? So unsigned long integer. If you want to store the more value, then they will go up to a very, very big value here. A long integer, they give a negative to positive for bigger number. Integer 16-bit, they given 2 bytes. Integer 32-bit, they given you 4 bytes, depending on new computer or old computer. Character, they given you 1 byte memory. Float, they given you 4 bytes. Okay? And double, they given you 8 bytes. That's just telling you how big they will be given you in the memory of the computer. Case sensitive. C++ is a case sensitive. Uppercase and a lowercase letter are considered to be different. I can give you here. You say integer height, okay? And later on, you say height equal 90. Then you get an error. The thing is lowercase letter, uppercase letter, quite different. That's what they said here, okay? They must be the same. Keyword just telling you if statement while for or man. Type depth. So we don't care about this one. The thing is you're not using it. Okay. For example, type depth unsigned short integer. They're using use short. Instead, you have to typing type unsigned short integer. You just typing use short and computer understand. That's just a shortcut. A constant qualifier. Okay, that means when they say constant unsigned short integer equal 15, okay, then specify the value of a variable will not change throughout the program, okay? So that means the value of VAL equal 15, and you cannot change in your program. Okay, the thing is you already said this is a constant. The phi constant with the phi. Then you start with the phi pi 314159. That's only thing telling you. Later on, whenever you type in pi and they computer understand, they equal 3.14159. And you don't have to type in again. Manipulator are operation used with instruction operator. That's what I just talking about, instruction operator. Okay. Modify or manipulate the way data is displayed. The end line manipulator insert a new line, same as last end. We're just talking about that. Set W, we don't care about that. That's just like when you type, okay? They can set it to bring in the certain field, okay? Numerical constant. So I skip that, okay? That's more programming, not in this program. And this is an example for enumerate constant. No, we don't need that. Statement we already telling you. On statement have to be n, semicolon. Why space ignore. Block and compound statement. On block begin with opening brace and end with closing brace. Anytime you open, then you must close. So that's why sometimes when the student typing the program in the main, you must be open the brace. However, at the end of the main function, they not close. So when they compile, you get one error. Okay? The thing is the compiler, first thing, they take the open and they take a close brace first before they do anything. And after you fix that, you close the brace and you compile, now you get 20 more errors. Okay? So someone told me, you get only one error. So now you can get 20 more errors. The thing is, after they fix, you open, then you close. And now you go inside your program. Then they can find inside more error. Okay? Anything expression, anything that evaluates to a value in expression in C++. An expression is set to return a value. Now, how much you understand that? You can say, I can say integer A, B, C. Okay? And now I say A equal 5, B equal 4. And C equal A. B. Okay? So any statement evaluate to a value. That means C equal A times B. And expression is set to return the value. What C equal? Easy, right? C will be equal 20.
20.
5 times 4. And that value will be returned. That means will be stored in C. Okay? All expression are statements. That means they must be end with semicolon. Operator. An operator in simple that cause the compiler to take an action. So basically you see the multiply here. That is what we call an operator. Multiply operator. Tell the compiler get the value in variable A time to the value on variable B. Okay, so operator symbol cause the compiler to take an action. Okay, that's what we call operator. Assignment, we already know the assignment. Math operator. If you adding, you're using plus, minus, multiply, division, modulus, increment, decrement. Increment operator plus, okay, and increase the value of the variable by 1. Like you say C equals C plus 1. Same thing you say C plus. Okay, in the path program, they're using C equals C plus. In the C plus program, they're using C plus. Either one, they're working the same thing. Decrement. Minus, decrement the value of variable by 1. Same thing. C equals C minus 1. The same thing you say C minus. Either one. Okay. Also, they can say C plus equal 1. What that means? C equals C plus 1. Also, C plus equal B. Also means C equal C plus B. Okay. Prefix and postfix. Prefix integer A equal plus 8. Mean increment 8. Then you can use. Postfix integer A equal 8 plus. That means use it then increment. Now, let's see. If A equals 5, then A equals 6 in the prefix. However, A still be equal 5 in the postfix. That's only telling you one thing. When you get integer A equals plus 8, no matter what you want to do, you must increment by 1. That's why x equals 5. Okay. A plus, automatically you get A equals 6. So now you understand what the prefix and postfix. Prefix increment right away. Then whatever you want to do later. But postfix is not increment right away. After you use it, you can increment. Okay? Precedent is the order in which the program performs the operation in formula. if one operator had precedence over another operator, it evaluated first. Now, operator precedence. The highest for precedence will be ... Okay, you guys not using. If they're using if you are a programmer, you will be using that in the pointer operator. Indirect membership arrow. Direct membership dot function. You see open close. Postfix plus plus, prefix minus minus, multiply, divided, modulo. That is a simple. Add, plus, subtraction, minus. And in the logical AND gate or gate, not gate, A and B, AND gate, or gate, and not. Okay? And now, relational operator equal. If you say A equal B, okay, if you say if, for example, if A equal B, whatever you want to do after that, but that will be wrong. This is, what is it here? This is simple here. What operator? Who's telling me what that operator equal?
Equals.
That's a comparison. You're comparing.
Relational.
Now,
It's an
we
assignment.
just get through it. What that operator?
Assignment.
Exactly. That's what I asking you. Assignment. Assignment operator. It's not equal. When you say if A equal B, then they have to be equal. Otherwise, A equal B, only one equal, they be assignment. Assign A equal to B. Okay? Okay, if not equal, you get, this is a simple for not equal. Greater than, if I greater than 10, okay, greater than or equal, this is simple. Less than or equal, okay, indirection operator, address of operator, ampersand y. Okay, now I can tell you. In the example here, A5B4, okay, if I said C out, okay, that one will be instruction operator, okay, and now I said value of A. And you know that is string constant. And now I inserted A. Okay, so basically, when the execution, the display value of A will be number 5. However, if I said I want to print different, copy that one. Okay. Now I want to say ampersand. Where ampersand? A. Can you tell me what they print it out?
The address.
What they print out?
Address.
Address, correct. Okay, then now in here, I can say address. Okay, and you can see they will be printed out by hexadecimal. Okay, they can print it out 0, I, 1, 1, 1, 1, 0, 0, 0, 0, 1, 0. That means binary. Okay, they bring it a real location inside the computer. Okay, if you want to see what basically really location inside your computer, you can display ampersand variable. Okay, logical operator. And if you learn digital on TechTube, you know AND gate, OR gate, NOT gate. If A and B, this is a symbol. Okay, if A or B, this is simple. If not A, this is simple.
Mr. Pham, question.
Yeah.
If you request the data to be printed using the ampersand and you think your memory is clear, you deleted or you formatted, what would be the expected value? Would it be a 0 or a 1 or all zeros or all ones? If we wanted to just test the memory to see what was written already.
Now,
But
if you try to clear or whatever you do, right?
right.
However, when you try to decoration, right here, they already given you location. Okay. That only when you run the program. If you not run the program, that will be deleted.
So if the memory is clear or deleted, what would be written in empty space? All zeros or all ones?
Now, you have to tell, you have to decoration first. If you don't have a that one, they not given to you. You get error. The thing is they not assign any location for you yet. You say integer A, they give an A location. If you say, I've given you example here. Okay, ampersand here, you say capital A. Now you get error. The thing is you not decoration. Declare variable A. So they don't have any location in your computer memory. Okay. So you must make a decoration first, so they can give a location in your computer. When you exit the program, everything clear. Okay. Now, library function. Many activity in C++ carry out by library function. This function perform file access, mathematical operate, computation, graphic memory management, data conversion. Basically, for example, to calculate the square of the number, then the first thing you must be include the map header. Okay, then you can set you using the function sqrt. Okay, for example, you using add
equal
qrt number 3, and they given you number 9. You want square number 3. Okay. However, before you can using this function, you must include the map. So what I telling you,
So map is the
everything-
library.
Just a minute. Everything
Yep.
you're doing in the C++, Microsoft already get on up the thing you need. However, you have to know which in library you want. You want the solving equation x squared minus 2x plus 5 equals 0. Then you have to using the math header. Okay? Microsoft do everything for you. So that basically they will be very easy. However, try to understand. Now, if statement. I said try to reading over and over and over. More exercise. Up to the certain point, everything you understand. No big deal. The if statement is used to test for condition, and then execute section of course based on whether that condition is true or false. This is the formula for if statement. First formula, the if statement, if condition is present, then they open the close, doing something. I given you example. I'm driving. I can ask someone, okay? Is it we go to eat? The answer will be yes or no. If it's yes, then you say, okay, no problem. However, if this direction go to the west, then the lot will be true. That means you get lot. Lot is be equal to, that means doing something. The thing is, before I start learning C++, I not quite understand. If condition is present, that means, the direction equal to it or not. If true, then what happened? Otherwise, you get lot, okay? You can say lot equal 4, okay? If you go west, then lot will be true, you get lot. Second statement, if condition is present, doing something, then you said else, doing something else. Okay, now you see the example. If the direction equal it, okay, if you go to the east, Okay, then the lot will be 4. However, if you go to the it, correct, lot will be, if you go to the it and basically get it wet, that means lot equal to L, then lot will be 4. Okay. This second statement, you get if L. Okay, I given you example. Is it raining outside? The question is it raining outside? The answer will be yes or no. Okay. Now, doing something. If it's yes, you say, I'm stay home. L. If no, I go to the movie. Okay. Try to understand how we can using if else. Okay. I said any question, any confusing, anything, just bring it up. We try to clear for you. Now, the last form of if statement. If condition, do what? L if you do what? L if you doing what? That means they can get too many L if. However, final have to be L. Okay? And now I can tell you.
Mr. Fan,
Yeah.
in general, the if statement that you just talked about and the else statement is basically a scenario that's saying if this didn't happen, your next choice, which would be else, you have to do this direction. You have to drive right or left. If you can't drive straight, right, or left, then your next choice is the next else. So basically it's saying if you can't drive straight, else is turn right. If you can't turn right, else is turn left. If you can't turn, else is turn around and go back home. Basically it's an option situation, correct?
Yeah, that's a different option. Okay, you can take one statement if statement. If you know, if we go to the west, they say yes or no. Okay. Otherwise, you get a second if statement. If then else, that means you get a decision depending on the if statement. That's what I said. Is it rainy outside? Answer will be yes or no. So if it's yes, what you do? Otherwise, what you do? If rainy outside, I say yes, and I say I stay home. Else, you have to get 2, not only 1. Okay? And now you can get if and too many L if. However, what I said, last one, they must be else. Now, I can tell you, I get, okay, A equals yellow. Okay. B equals green, just a ball. C, okay, equal blue. And D equal red. Okay, basically you get 4 balls with the color inside the box. Now you pick the first one, A. You pick the first one. The question is it yellow? Now, you looking for the red. Is it red? Okay. The answer will be yes or no. Now, if it's not red, then you go the second one. Okay, is it red? No. And you go the next one. Is it red? No. And the last one, no more add. They have to be red. You see that? That's why the last one have to be else. The first one, you can say, is it equal red? No. You go L if red, no. L if red, no. However, the next last one, you cannot say L if anymore. They must be F. That means they must be red in this one. That's just a formula. You learning, you understand C++, just using formula. You have to follow, understand, and follow it, then you can do.
Well, that's your example. So technically, we can apply a voltage to red, and red won't turn on until it's 2 volts. But yellow, green, and blue could be 1 volt, 2 volt, 3 volts. But at a certain voltage, red will turn on. So it doesn't necessarily have to be alphabetical. It could be something very specific as a voltage, so that an LED could be turned on, or you get a certain message, right? I understand. Thank you.
Okay. Let's see. Wow. While loop causes your program to repeat a sequence of statements as long as the starting condition remains true. You see that? Wow condition. Okay, then statement. So while x less than 10, then go ahead and bring out x value. Okay, if x still less than 10, they can keep going. That is just a loop doing 10 times. Okay, now continue statement. Cause a while or for loop to begin again at the top of the loop. You understand when you go into your ATM, they can display number 1, deposit, number 2, withdraw, number 3, exchange, or number 4, quit. Okay? So when you enter number 5, and they cannot recognize, okay? In the path software, they can telling you, go to the top. That means they try to repeat display for you, okay? However, in C++, they're using continue. So after you enter number 5, some wrong, they continue. They bring up you to the top of the menu, bring again. Okay? If you're doing 3 times, they take your car. Okay? The thing is, when they try the program, they don't want using go to statement. Okay? In the past, everything you need, you have to go to somewhere. But C++, they can try to get away. Go to statement. Break statement. Caught the immediate end of a while or for loop. Execution jump to the closing brace. For example, while condition. If condition 1 break. Okay. Now, when you're learning a little more, you can see I'm using a for loop for integer I equal 0. Okay. I less than 1,000. Then I plot. That's only telling you what happened. That means they do how many times? They do 1,000 times. Okay? Then you must be open the break in here. Okay? And you can say Cout. That means you want to print. Okay? I. Okay? That means you print the value of I. Then you close. They will be doing 1,000 times. However, for some reason, you say, if I equal 100, you don't want to do any more. That's why they're using break. Okay? So you can adding in here. Okay? If, okay, I equal 100. Okay? Then you say break. Okay? So if I equal 100, they get out that loop. They do up to 100. No more. That is the purpose of the break statement. Okay? When you have the thing that you understand, when you're working with the software they're using for statement, instead have to enter the data for 10,000 people, and they have to using for statement for I equal 0 or I equal 1 up to 10,000, and they keep enter the data. Okay? Without that for statement, they cannot do the job. However, for some reason, you want to get out that loop, then you can using break statement. Okay? Do while. Basically, when you try to do something, okay, then you don't have to memorize formula, but you know where you can looking into that. Do while loop. It is possible that the body of the while loop will never execute. The while statement check its condition before executing any of its statement. Do while. The do while loop execute the body of the loop before its condition is tested, and ensure that the body of always execute at least one time. Okay? Syntax do. Okay? Integer x equals 0. Okay? Now they say do Cout I blood while I less than 10. Okay, that means if I still less than 10, then they still do it. Okay, that's why they say while I less than 10. That means when I equal 9, okay, they can do it. However, if I equal 10, they get out the loop. Okay, and now the for loop for initialize test action. That's what I just given to you here. For, okay, initialize. That means I initialize I equal 0. The next test, okay, that means I less than 1,000. And the next one, what action? Increment I by 1. So the first thing I 0, you do it, and the increment I to 1, they still less than 1,000. Keep doing, okay? And this is the formula, okay? You can see that for I integer I equal 0, semicolon, I less than 10, semicolon, I plus. You have to follow exactly. Cannot be different. Different, then you can get error. So that's why some people already know how to do. Okay? Then when they see the error, they know right away what they did wrong. Like when in the past, students get error, they need me help. I looking into that error, I know right away what error. Okay, switch statement. Allow to branch to any of a number of different value. Okay, switch expression. Case, value 1, break, value 2. You understand it? That's what happened in your ATM. They using the case statement to write a formula. Okay, switch case number 1, deposit. Number 2, withdraw. Number 3, okay, exchange. Default. If it's not up there, quit. Okay. Okay, so basically that's it. Only thing is your job will be anytime you need, open the handout, looking into related thing, and you can find out what's wrong. When you try edit your program, first thing you have to compile. Compile, that means the compiler check on off the thing you're doing. Is it they meet the requirement? Like after each statement, they must be at semicolon. If you're using the switch, how can you deal in that? That basically just a formula. Okay. So any question about C++? We go only one time. Okay. Okay, so now I'm using my iPad. Okay, before we start on that transistor, any question? Okay, let me get some to drink. Okay, you get any question or anything else? Otherwise, we start with the bipolar transistor. So the first thing is, you can see you get a two symbol for the bipolar transistor. That's what we call a NPN transistor. Definition will be, this what we call a base. This will be a collector, and that will be emitter. And the current flow into the base, that will be IB. Current go into the collector, that will be IC. And the current leaving emitter, IE. That will be NPN. And the second one will be PNP. If you're looking on the symbol, you can see the different name. Emitter here, arrow pointing out. On PNP, arrow pointing in. That will be PNP transistor. And you still get the same. This is the base, collector, and emitter. However, the current at the base leaving, current collector leaving, current at the emitter go into it. Okay? And this is the formula. Okay? IE leaving equal IC plus IB. That apply for both NPN and PNP. Okay? And if IC very close, IC almost equal IE, if IB is too small, but we don't care that. Okay? And also they given you two definition for alpha equal IC divide IE, and the beta equal IC divide IB. That is the formula you need. Now I go into little physical. First thing we're talking about NPN. NPN, you get a N and P. You understand NP just a one diode. Okay? NP just another diode. In the N area, they contain electron, and that will be hole. Okay? In P. NPN transistor construction. Basically, when another section of PN material added to PN, diode junction, a three-section device contain two junction formula. So basically, they just two diode. You can see NPN, okay? Then you get a one diode here. Another diode here. Okay, so NPN. Okay, you get a D1 and D2. So that will be a collector, that will be an emitter, and that will be the base. So basically, you get a two diode combined, you get transistor. Okay? Either NP, NP, and P. For PNP, and the diode will be go this way. Okay? That will be PNP. So that's only thing. Make sure you know inside the transistor, you get just the two diode. And there's a little more here. Okay? They given to you. That will be NPN. You see that? One diode here, one diode here. One diode from the base to the collector, one diode from base to the emitter. That will be the same for PNP. Okay? And just given you, that is just simple. Real transistor. Okay, now you can say this is NPN. That will be PNP circuitry. So this is NPN here, you get a voltage VBB connect to the base. And also you get a VCC connect to the collector. Okay? And the differently for PNP, VBB will be connect negative. And VCC also negative. That's a difference between NPN and PNP. Okay? Now, this is a DC bias. What that means? DC bias, that's telling you the transistor needs the power, DC power, to make it work. Okay? Without the DC power, transistor cannot work it. They get two different parts. One DC voltage needs to make the transistor working. And the second thing is transistor will be using as an amplifier. Like they can amplify your voice. Okay? However, without DC bias, they cannot do anything. This is one way to make the transistor working using two power supply. We're talking about NPN. Okay? So, how many things we need to know? You understand it from the base to the emitter, you get a diode here. Also, you get another diode here. Okay? From the base to the collector. So when you apply the VBB into the base, then you get the current IB go to the base and the current IE leaving, current IC go into here. So they already telling you how do we calculate the IB, current IB go here. Okay, so they get the loop. Okay, first thing you go to minus VBB plus IBRB plus 0.7. The thing is diode on, they will be 0.7 volt. Okay, and finally, they given you want to calculate the IB. This is the formula for this circuitry. VBB minus VBE divided to RB. And after you get the IB, you can calculate the IC or IE. IC equal beta times IB. IE will be using 1 plus beta. IE equal 1 plus beta times IB. Okay. And if you want to calculate the voltage across RC, so the current flow is IC, then the VRC will be IC times RC. Now, if you want to calculate the VC, the question is, if I given you the meter, I telling you, okay, go ahead, measure VC here for me. How you connect your DMM? If I want measure VC, you have to tell me DMM high connect where? DMM low connect to where? If I want to measure VC, can you tell me DMM high connect to where? DMM low, where the connection?
The high,
Highs at P, lows at E.
Come on.
high on C and low on common.
Exactly, that's what I'm telling you. High connect to C and low connect to the common. That means the round. They're telling you one thing. When they want to measure only single point, I want VC, okay? Then DMM high. C, DMM low. Now, they both be common. If I say I want VB, same thing. That will be telling you high side connect to B, low side must be connect to ground. However, if I say I want to measure VRB, how do we make the connection? VRB. That means this one. Okay. VRB means measure the voltage across RB. High side connect here and low side connect here. Okay. You get that? If I want to measure VCE, how do we make a connection? High side connect to C, correct? Low side connect to E. That means VCE. Okay, any question? If it's not, can you do this for me? The thing is, you guys have to work with me. Otherwise, we cannot do anything. This just like in class. But in Zoom will be much better. However, you have to cooperate it. Go ahead and calculate it, telling me what you get. Okay, what VBE?
So 0.7.
Yeah, 0.7, correct. IB, IB, we already give formula, okay? VBB minus 0.7 divide RB. And if you want to calculate the IC, beta time IB, you want IE, just a formula. 1 plus beta time IB. Okay. If you want to calculate the VC, you can using VCC minus IC. In here, I can see easy, that will be 0. VB, what VB equal? VB means from the base to the ground.
Is that 4.3?
VB, that will be telling you from here to the round here. What's the value?
But we already said it's 0.7, no?
Exactly. Okay. And the other one, you can see what the VE equal. What VE? they connect to the ground. So that's why they be equal 0. Okay? And the red IB, I already given you the formula.
IB is 0.4 milliamp.
0.4 milliamp. Let's see. I try to calculate for you 1. Okay? You get 5. Okay? Minus 0.7 equal 4.3. Divide 10. 10K. 0.43. Right?
Yep.
And now you get IC beta equal 150. Okay, so you guys do it. We're not trying to stay longer in this one. If I already given you the formula and you still cannot get the answer, maybe you need to quit it. Okay, now, region of operation. Basically, the transistor, either NP, 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 same thing. They get a cut-off region. They're using in the switching application. That means on and off. Active region is for linear amplification. And the saturation, same thing, is in switching. And basically, saturation will be using for logical circuitry. That means they can be using the AND gate, OR gate, anything. Okay? But they have to be in saturation. They cannot be amplified. So if you're looking inside the AND gate, OR gate in a texture, you can see inside just the transistor. Okay? Breakdown can destroy the transistor, we don't care that. Okay. Cut off diode from B to emitter is off. When the transistor is cut off, you can see inside the gate 2 transistor. They will be off. That means they will be open. So no current can be flowing. That will be cut off. Active. When they active, the diode from the base to emitter will be on. However, the diode from the base to collector will be off or reversed by, okay? For the saturation, both diodes are on. And also VC to E almost equal 0 volt. That's a very basic definition for what happens if they cut off. What happens if they active to be amplified? And if they saturate, and what happens? Okay, you need to know, understand that. Okay, now, for the transistor circuitry here, what AVCE? That means that will be C here. That will be B here. That will be E here. Okay. When V in equals 0, what the voltage here? You can see I already get a solution for you. However, I want to know how come VCE equal 10 volt. Who can explain to me? First thing they're telling you, input is 0 here. So the transistor will be off. When they off, you get a one diode here, they open. So the current okay, IB 0, IC 0, IE 0. No current. Okay? And how come V from C to E equal 10? So what is VC? What is VC?
ten
10.
because
Now-
there's no current.
Okay, that's correct. Now, you can see the IVRC right here. VRC, IC, time, RC, 0 volt. The thing is IC equals 0. So you get a 10 volt here. They drop 0 volt here. Then VC have to be 10. And VE 0. So VCE means 10 minus 0 will be 10. So that's why VCE equal 10 volt. I already gave it here. Okay. Since the transistor is saturated, what minimum value of IB is required to saturate this transistor if the beta equals 200? Okay, so now this one you need to read. Since transistor is saturated, means VCE equals 0. That's what we already talking about the previous one. Then IC saturate will be VCC divided to RC. Okay, that means this is 0 volt. So the voltage, okay, of the IC will be equal VCC divided to RC. 10 volt divided 1K, you get 10 milliamp. Therefore, IB equal IC, okay, divide to the beta. And beta equal 200. So you take 10 milliamp, divide 200, you get 50 microamp. Okay. Calculate the maximum value of RB when V in equal 5 volt. when the transistor is on voltage across RB, okay, equal V in minus VBE. That means right here, 0.7. That means the 4.3 voltage across here, okay? Then RB maximum will be equal to VRB divided IB minimum. So you get 86K. So if the trend, you can see number B. It says if the transistor is already saturated, then the current IC will be equal to 10 milliamp. Okay. And if they saturated, they want to recalculate at the saturate what IB equal. And you see IB equal IC saturate divided to the beta. You get 50 microamp. Okay. So that is the minimum. Okay. IB is minimum. So now, when the transistor is on the voltage RB, you calculate the voltage across RB, and you take that VRB to divide IB. You get the value for RB. Okay, that means minimum value for RB to be saturated. If you get the current, you change the resistor on the RB. Okay, make the current higher than 50 microamp, then they be saturated. If you don't want saturated, then the current IB have to be less than 50 microamp. If you want the current IB less than 50 microamp, then you have to select the RB. Okay, minimum 86 kilo ohm. And the value has to be equal 86 or higher. Okay, try to understand this thing. The graph of IC versus VCA. Okay, now you can see in here. First one, this stands for IC. This will be stand for VCE. That's VCE. Okay, what is it here? $20 microamp, 40, 60, 80, 100. What is it? For each one, stand for what? Who knows? What equal 20 microamp or equal 40 microamp? What is it?
Is it the IB?
IB. Okay? So this IB equal 20. IB equal 40. IB equal 60. Okay? So when the IB changes, and the current IC here will be changing. I'm giving you the example. If you stay right here, they're telling you IB equals 60 microamp. You want VCE, you going down. VCE equal 10 volt. And you want IC, you go to the left. Okay? So IC can be equal maybe 8.3.4. So basically, current IB will be control the transistor. So that's why they call a bipolar transistor a current controller. You changing IB, you changing IC and IE. Okay? So that's what you must know. Bipolar, yeah, current controller device. Why? Why current controller? The thing is when you changing IB, you can changing IC. Okay? And changing VCE, for example. Okay? And now, in here, they get the 3 regions. One part right here. That area for saturation. Okay? And the part down here, they will be cut off. We already know. We already telling you. Transistor will be either cut off, active, saturation. Again, cut off. That means IB, IE, IC equal 0. They're using for the switching. That means just on and off. And also, this area is saturation. Saturation, the same thing like switching, but they're using in buildings IC in the digital circuitry. Now, the last one will be active. That means amplifier. So this part right here will be active. Okay? This is cut off. This is saturation. And in here will be active. So that will be helping the people try to design using the bipolar transistor. They have to know what they want. They want to cut off, or they want to saturate it, or they want to amplify it. Okay? Active here for amplifier. So now I give you an example. I can pick the point right here. That's what they call a Q point. So at the point Q right here, you can get the IB. Okay, 60 microamp. Go to the left, you can get the IC. Going down, you can get the VCE. This is Q point here. They want to build amplifier. Okay? They want to build amplifier. Any point here will be for amplifier. However, they don't want to pick the Q at this point. Okay? You know why? They don't want to pick a Q here. How?
Too close to saturation.
Exactly. They don't want to pick very close to saturation. The problem is when the transistor gets heated up, the Q point will be little moving. So when you want the transistor to be amplified, amplify your voice, you don't want to be saturated. The thing is saturated, no more amplifier. So they don't want any point close to the saturation or close to the cutoff. Okay? They can be cut off, that means no more amplifier. So normally they pick in the middle. If you want to design the circuitry to be amplifier, then you have to get your Q point first. Okay? Like example, you pick your Q point here, and you know IB already. You know VCE already, and you know the current IC. Your job now will be select resistor IB, RB, RC, RE to get the current you want. Okay. Now, that's what they're talking about, the load line, DC load line. You can see you get a point A, point B, and you get a line. So if you get right here, you can get that a Q point. Okay? So you can get IB, IC, IE. However, now I show you how to draw the DC load line. First thing, they say, point A at saturation. Okay? I saturate equal VCC divide RC. Now, you're looking into this circuitry here. VCC 10 volt divide 1 kilo ohm. Okay? Then you can get IC at saturated equal 10 milliamp. Okay, that will be milliamp. That means you get a 1 point. And the second point, point B, cut off. Point B, cut off VCE. That means this is VCE equal VCC. That means at this point, you get 10 volt. Okay, so basically you get 2 points. One in IC, one in VCE. Draw the line, okay? And they cut the IB at certain point. That line they call a DC load line. Okay, make sure you understand. If we want to draw DC load line, then you need to get 2 points. Point A, point B. Okay? How we get point A? You take the VCC divide to RC. That you get current IC. If you want the VCE, and basically VCE will be equal VCC. Okay. Okay, quickly, then we can get it done. Now, we already talking about and bipolar, they can be amplifier, they can be saturated, or they can be cut off. This will be talking about cut off. Cut off means diode here, open, not working, so no current, IB 0, IC 0. And basically, they get like the switch open, okay? And this will be saturation, okay? So when they saturated, the voltage here is almost 0. So basically, they will be connected from the collector direct to the ground. Okay, so that will be show you what happened if they saturated and what happened if they be cut off. Okay, and basically we already telling you, you get a one diode here, one diode here. Okay, one from B to C, one from B to E. Okay, so for the cut off, that means both diodes open. For the saturation, both diodes will be active. However, for the amplifier, then this diode B to E must be on. However, diode from B to C must be off or reverse bias. Okay, up to this point, any question? Okay, so if it's not, for sure, you guys try to review it, go over. Okay, we can get more next meeting. So tomorrow we'll be meeting for Tech 2. In you Tech 1 don't have a class. So you want to go into see what's going on Tech 2. I welcome. Okay, that will be giving you more knowledge. Okay, I stopped it, guy. Okay, any question, anything?
Thank you, Mr. Pham. Good class. Have a good night.
Thank you.
Good night. Good night, everyone.
Good night.
Good night.